When I checked the program, I was kind of worried because previous speakers included composer Kim Young-seok, who gave a wonderful speech and delivered wonderful performance. So I thought I cannot continue because I cannot beat his performance. But he also gave a talk, so I was kind of relieved because I thought I would be a better speaker. But I was really impressed by his insightful talk, so I'm very nervous right now. I'm the evolutionist, and I am studying the evolution of the nature and also the evolution of the corporate world. When we look at the natural world, we see two obvious things: diversity and incredible sophistication. When you look back on the 4 billion year history of life, we realize how diverse life has branched out. However, more than 90% of life has gone extinct. In other words, nature has been experimenting with survival and extinction for 4 billion years. What can we learn from this? The ecosystem of the corporate world is similar. Only 12% of the Fortune 500 companies from 66 years ago are still alive. The average lifespan of a company in the S&P 500 was 33 years in 1956, 22 years in 2021, and is projected to be 16 years in 2027. According to a U.S. Bureau of Labor Statistics, about 20% of startups fail in their first year, and half of them fail within 5 years. The world of corporations and the world of nature have similar patterns of fate. So what types of companies survive longer, and what are the evolutionary characteristics of companies that survive over the long run? We look to the principle of survival and ultra survival found in nature to help us understand those of corporations. In the natural world, organisms must solve two problems. The first is survival, and the second is reproduction. The leaf beetle in the photo on the left has evolved to look like a real leaf, not just the leaf veins, but also the shape of the bug bite. The male peacock on the right has evolved to have these colorful but unwieldy feathers to be an attractive mating choice for females. Nature favors creatures that are good at surviving and reproducing. Darwin summarized this mechanism as natural selection and sexual selection. In the first edition of On the Origin of Species in 1859, Darwin proposed the theory of natural selection to explain the diversity and sophistication of the natural world. The three conditions of natural selection are variation, differential fitness, and heritability. Later, scholars defined these three conditions as necessary and sufficient conditions for evolution by natural selection to occur. There are principles of survival. First, most will fail. Second, there's always competition for survival. Third, there's no evolution without variation. Fourth, selection of the environment is important. Fifth, we need to pass on the secrets of success to the next generation. Let's call this Evolution 1.0. But can Evolution 1.0 explain ultra survival, not just survival? Nature has created great transitions that put us on the path to ultra survival. Evolutionist John Maynard Smith and Shatmari identified 8 great transitions in the world of life. For example, the evolution of sex-amplified genetic diversity on Earth, the evolution of multicellularity was a watershed in the differentiation of life into plants, animals, and fungi. And the evolution of social animals led to a massive increase in productivity. Finally, the language, or human beings, was a tipping point that led to an explosion of new designs. Although not included in these 8 great transitions, the first appearance of a body segment in nature is a great example of ultra survival. After the first appearance of segmented structures, an enormous diversity of life forms emerged during the Cambrian explosion. The preceding transitions and the speciation are the emergence of systems that facilitate the occurrence and generation of favorable variation. This characteristic of systems is called evolvability. A structure with evolvability is also generate diversity and respond flexibly and robustly to changes in the external environment. A classic example is the development of the Hox genes. This gene is a development gene that determines the identity of body segments in fruit fly embryogenesis. Surprisingly, for scholars like us, is equally involved in embryogenesis, not only in fruit flies but also in mice and humans. By varying the number, combination, and so on of the Hox genes, we have modified the animal kingdom. In other words, nature built fruit flies and humans out of the same Lego blocks called the Hox genes. Once they were created, they become the basis for all animal development. You could say that Hox gene is a common, essential building block that was used to create a wide variety of animals. It's a prime example of evolutionary forces at work. Then, what creates evolvability? The secret lies in modularity. A module is a unit of specific functionality, for example, engine parts, air conditioning, wheels, etc. All components work as semi-independent modules to make up a car. This means that if a wheel breaks, you can just replace it, but you don't have to break the whole car apart. Modularity comes from satisfying the conditions of integration, quasi-independence, and hierarchy. In this figure, the components inside submodule 1 have tight connections between them. This is a very cohesive unit. This is internal integration. The connection between submodules 1, 2, and 3 are very loose, so the failure of one module does not spread to other modules. In other words, each module is a quasi-independent. Also, more complex parent modules are hierarchically organized into less complex submodules. If evolution 1.0 was the evolution of adaptation, evolution 2.0 is the evolution of evolvability itself. Organizations with strong evolutionary forces will survive through any catastrophic event, even the great apocalypse, no matter when they were born, as long as a few billion years ago or as short as the 300,000 years ago. Applying modularity, a key element of evolvability, to corporations, it means that there is a variation-producing organization, and flexibility means that there is an integrative diversity through connectivity and collaboration. Robust in the corporate world means that there is a structure that prevents the failure of some teams from spreading to the whole. So let's look at some examples of companies with modularity as a key element of evolvability to help you understand this concept. The Horizon strategy that Google successfully practiced was a strategy about strategy. It's a strategy that focuses 70% of the company's energy on its current core business, 20% on emerging businesses, and the remaining 10% was to focus on the business of the future, a few decades from now. So these would fall under the category of adaptive potential. Even if Horizon 3 fails, the rest won't take a hit. This is about robustness. I would call 70-20-10 the optimal ratio, but you will need to adapt it based on the nature of your organization and your situation. Look at the modular organization that created the evolvability of Google's parent company, Alphabet. There's C, Calico, which is realizing the dream of a life extension, and there's D, DeepMind, and the W, so Waymo. And there's a YouTube, Y. So robustness and adaptive potential and the flexibility of the Alphabet group are very evident. Let's take a look at another company that is using modularity. You will know agricultural equipment company, JANG Dayk. It chose to pursue digital transformation to solve fundamental problems in agriculture, and it pursued mergers and acquisitions. It has greatly increased their adaptive potential, flexibility, and evolutionary power. It acquired an AI company to maximize the efficiency of a farm machinery. So if you look at the screen, two cameras mounted on the front of the computerized cab scan crops to automatically set and maintain the combined forward speed based on the crops directly in front of the header. Agriculture has entered a new phase because of this kind of transformation. Some companies are more evolvable than others in terms of organizational structure. A core organization maximizes the existing business model attached to an edge organization that tries to innovate. There is also a structure that increases adaptive potential, flexibility, and robustness. We discussed that the key to ultra survival is evolvability, and a key component of evolvability is modularity. So you need favorable variation or adaptive potential, and you need robustness, and these are characteristics of a modularity. Google, Alphabet, and JANG Dayk are examples of companies that exhibit most of these three characteristics. Other companies are also highly evolutionary. For example, there's a SpaceX, which has an organizational culture that encourages a failure. And there are examples of flexibility, such as Tesla and NVIDIA. And Apple is able to create an ecosystem where different types of devices are connected to each other to create great synergy. Netflix is building a stable portfolio of content through a variety of content delivery channels, and Amazon and Microsoft are able to recognize a failure as a single failure and spread the lessons learned. So let's summarize once again. The characteristic of a super survival company is evolvability. It is the ability to generate beneficial variation, and it's essential for a company to move beyond survival and into the realm of enduring success. And when you have a modularity, you will have adaptive potential, flexibility, and robustness. Although we live in a time of survival, today we are reminded of the principles of ultra survival throughout the 4 billion year history of our life. So evolvability is an ultra survival force that creates sustainable innovation. Are our organization playing the game of survival, or are they playing the game of evolvability? Thank you very much for your attention.